Hello, Cougars. I hope you had a wonderful Thanksgiving break. I sure did. I ate a lot, and now I need to exercise a little bit more to get rid of that extra turkey that I ate. Anyway, remember, before the break, I asked you to pay attention to measuring. Did you help in the kitchen? Did you help measure things for cookies or cakes? Did you pay attention to the temperature that you cook in the oven? Is it at 350 degrees? When you cook something on the stove, was it on high heat or low heat? It's really important in science to measure things. And now we're going to start talking about measuring the temperature. So over the next 2 weeks, we're going to be really focusing on temperature and what happens when things get hot or cold. Now, we're going to be doing 3 experiments, and not everybody has all of the materials to do all 3 experiments. I just didn't have enough materials for every single person. So some of you got a thermometer. Some of you got a little vial on a stick. And some of you got a bottle and a stopper system. And everybody is going to get to do one of those 3 experiments over the next 2 weeks. We're going to start by showing you a pretend thermometer. Now, I like to call it a thermometer because the word therm means heat and the word meter means to measure. So a thermometer or a thermometer measures heat. So here's my thermometer and my pretend thermometer, and at the bottom of the thermometer there's this bulb, and it's full of a red liquid. And the red liquid is like rubbing alcohol, because rubbing alcohol really responds to changes in temperature. So what we're going to do is we're going to put the bulb into a liquid, and then the liquid is either going to go up or go down depending on the temperature of the material that the thermometer is in, okay? Now, this thermometer, I want you to see how you read the thermometer. First of all, it's in degrees Celsius. And second of all, you see that there's a 0, 10, 20, 30, 40, 50. So it's in increments of 10. And then there is like a bigger, darker line, that's a 5. And each one of these is a 1. So let's just talk about how we read the thermometer. So I'm going to look at it here. So you go from the bottom all the way up to the top, and this is 20 degrees Celsius. In science, we measure in degrees Celsius. So 20 degrees Celsius. Now I'm going to change it again. Okay. So this one is 0 degrees Celsius. And 0 degrees Celsius is a very important number because that is the temperature where water freezes into ice. Okay, I'm going to do another one. Aha! 15 degrees Celsius. So you go up from the bottom. Here's 10. Here's 20. And this is in the middle. 15 degrees Celsius. Okay? So that's how you read the thermometer. Now, let's actually use the thermometers that you guys have. Okay, so we're going to start using a thermometer. And I would like you to get these 2 Science Notebook Masters. So the first one says measuring temperature procedures. So this is the procedure we're going to follow. If you want, you can glue this into your notebook, but you don't have to. But then I want you to actually glue this one into your notebook, measuring temperature number line. So please glue this into your science notebook. So if you have the thermometer, what you need to do is you need to have 3 cups of water. You need to have 1 cup of water that has ice in it. you need to have 1 cup of water that is hot, not boiling hot, just get hot water from the sink. And 1 cup of water that's just room temperature. So just take it out of the sink, don't put any ice in it, but it's not the hot water from the sink. And now we're going to look at what happens to the thermometer when we put it in the different cups of water. I have labeled each one of my cups A, B, and C. A is the cold one that is with the ice. B is the hot one. And C is just the normal temperature that comes out of the sink. So now let's take a look and see what happens to the thermometer. I've got my 3 cups, and I'm going to start with cup A first. I'm going to put here's my thermometer, and you can see right now the temperature on the thermometer is about 20 degrees, just above maybe 21 degrees. And I'm going to put the red bit in the bulb into the ice water, and you can see that the red liquid is going down. I would say that the temperature, it's still going down. It looks like the temperature is about 3 degrees Celsius. So now let's take a look at our number line. On my number line, I have 0, this is 10, this is 5, 1, 2, 3. So I'm going to put a line right there, and I'm going to write a letter A on the left side because that is cup A, and it is 3 degrees Celsius, and I've recorded 3 degrees Celsius in my notebook. Okay, now I'm going to go to cup B. Okay, something very different is happening in cup B. Instead of going down, the thermometer is going up. The red liquid is going up the tube, and the temperature is 45 degrees Celsius, and this is cup B. Now I'm going to go to my number line, and here's 40, there's 50, in between is 45, so I'm going to put a line there, and I'm going to put cup B, okay? Now I'm going to get my thermometer, and I'm going to put it in just regular tap water that came out of the sink, and it is not as hot as the hot water, and it's not as cold as the cold water. 20 degrees Celsius, and it's cup C. So I'm going to find 20 degrees Celsius. Here's 0, 10, 20. So I'm going to put a line at 20, and I'm going to put cup C. All right, so now I've recorded what the temperature was of those 3 materials in my science journal. Okay, now the next thing it says, write hot by the temperature of the hot water. So which one of these was hot? A, B, or C? B, right? B was the hot water. The next thing it says is write cold by the cold water. Which one was cold? A, this was the cold water. Now it says make a prediction. If you were going to mix the hot and the cold, what do you think the temperature would be? So make a prediction and write a P where you predict the temperature will be. I'm not going to show you my prediction. I want you to do your own prediction. I put half a cup of ice water and half a cup of hot water together, and the mixture is 24 degrees Celsius. So I'm going to add my mixture here 24 degrees Celsius, and I'm going to write mixture. You noticed I did not write my prediction because I wanted you guys to make your own prediction. Another experiment we're going to do is we're going to add some water to the bottle and have the rubber stopper. I added some food coloring to the water so that we could see it better. You don't have to, but I did just so we could see it easier. And now I'm going to put the rubber stopper in the bottle, and it's a little bit hard to put it in. Okay, so this is what my bottle looks like now. I have a little bit of water. I just tip that over, make sure I have a tiny bit of water coming up out of the tubes. I put the rubber stopper in, it pushed the air down and pushed some of the water up the tubes. So now what I'm going to do is I'm going to put it under a heat lamp, and I'm going to check on it about every 30 minutes to an hour, and we're going to see what happens to this. If you have the bottle and the stopper, you could, if you needed to, you could put it together like this, and you could put it in the microwave for 30 seconds so you can see what happens quickly. But I'm gonna put mine under a heat lamp. So I have now put my bottle under this heat lamp, and you can see just a little bit of green water going up the tube. And we're gonna see what happens as time passes and the water gets hotter. It's another 15 minutes, and over time, the water is getting hotter. And it also appears that the water is being pushed up the tubes, or somehow is moving up the tubes as the water gets hotter. While we're waiting for the bottle and tubes to cool down a little bit, I would like you to get out this page for your science notebook, bottle and pipe system, okay? And it says record and label the water levels. So where did you put the bottle system? I put mine under a heat lamp. You might have put yours in a microwave for 30 seconds, but I'm going to write under a heat lamp. What did we observe? What did we see happen to the water? The water went up the tube. And now we're gonna wait and see what happens now that we're putting it in some place where it's cool. So we could say, where did you put the where did you put the bottle system? And I'm gonna say, out of the heat. So someplace where it's cool. And now we're gonna wait and observe what happens as the water cools. Okay, so it has been about an hour, and I let it sit for a while and not much was happening. And so instead of just letting it sit in the open air, I put it in an ice bath. And once I put it in an ice bath, the water level started to drop. So when the water level started to drop, the water took up less space. So I'm going back to my science journal, and what did you observe? Well, I also changed it. Where did you put the bottle system? I put it in ice. And what did you observe? The water went down the tube. And explain your observations. What did you observe? Well, that when water gets hot, it takes up more space, it expands. When water gets cold, but not frozen, it takes up less space, it contracts. Okay, we're gonna continue exploring temperature and heat and cold next time. See you next time, Cougars.